Hello everybody, today we're all about electrolytes, which I think a lot of us have heard of. Here's the objective. Electrolytes are really something called an ion. That's the way we're going to refer to them. And so what's an ion? An ion is an atom that's lost or gained electrons. And when it does that, it gives it a charge, either positive or negative. And the reason this is important is because electrolytes are in our bodies and it helps us function in a certain way. You see Messi there in the picture drinking a Gatorade, which has got electrolytes in it. So he's replenishing his electrolytes. And also, electrolytes are all in the environment. And sometimes they can cause damage. They can be pollutants. And so we've got some notes for you here. If you were in class with me, you've got something just like this in your notebook. So why don't you get to that page? And if this is new, hit pause and jot down the skeleton of notes. And so our essential question is, what are electrolytes? How do they form? And why are they important? And so, like I just mentioned, electrolytes are simply called ions. That's the way we're going to call them in chemistry. Electrolytes is more for marketing and Gatorade and things like that. They're really ions, and that's that atom that's lost or gained an electron. Remember, electrons are negatively charged, minus charge. And so if you gain a bunch of minus charges, it makes you negative, or if you give some away, it makes you positive. And we'll talk more about why. So here's some vocabulary for you. First word is cation, cation, and it's just what you call an ion with a positive charge. So you see magnesium, it's got a little 2+ charge there. It's an example. How do you remember cation's positive? I look at that T there and it looks like a plus sign to me. So that's how I remember. The other one is called an anion, and so that's the other one, which is an ion with a negative charge, like chlorine, which means it's gained negative particles to make it negative. And so how do they form? Write this down for valence electron. The valence electron is the electron that is in the outermost shell of an atom, the outermost orbital. And so whatever's there, we call that the valence electron, and they're super important, and it really affects how atoms bond to make molecules or compounds. And so atoms want to have a full outer shell of valence electrons. If they don't have that, they're not stable. And so there's two rules, and they're pretty easy. One of them is called the octet rule. And if you think about oct or octopus, how many legs does an octopus have? 8. How many electrons do most atoms want? 8 valence electrons. So that's the octet rule. In the outside shell, most atoms want 8 valence electrons, and that gives them a full shell and makes them stable. And so they'll either lose electrons or gain electrons to make it so that outer shell has 8 valence electrons. But there's a couple of atoms that are pretty small. Remember, the first orbital, the first shell of electrons, can only hold 2 electrons. And so that's our duet rule, 2 valence electrons. And so if the atom's small and it fills up that first shell, it can be stable that way too. Okay, and so here we go. I want to show you a couple examples. This is good review. And so I'm looking at magnesium right now. This is what it looks like when it's in its pure form. It's a metal, a soft metal. And if you look here, this is from the periodic table. Magnesium has a atomic number of 12. What does that mean? It means it has 12 protons and 12 electrons. And so I diagrammed it down here. 12 protons, 12 electrons. And it's got a mass number of 24.305. That means two things. One, it tells you how much a mole, 6.02 times 10 to the 23rd atoms of magnesium weighs, which is 24.3 grams. But it also tells us how many particles are in the nucleus. Remember what's in the nucleus of an atom. It's protons and neutrons. And so if we know 12 of those particles are protons, here, look at it, I rounded that off. 24.305 equals 24. We're going to round down. It equals protons plus neutrons. If we've got 12 protons, that means the other 12 must, or the other number must be 12, because 12 plus 12 equals 24. So 12 protons, 12 electrons, 12 neutrons. Protons and neutrons are in the nucleus. Look at, there's 1, 2 electrons on the first shell, 1, 2, 3, 4, 5, 6, 7, 8 on the second shell. So that's a total of 10 so far. 11, 12. And so it's got 2 electrons on the outside shell. Those are the valence electrons. So I put down 2 there. But it's not happy. It's not stable. But right now, if it's got 12 plus charges, there's my 12 protons, and 12 minus charges, my electrons. If we put all that together, the total charge of this atom is 0. But it's not stable. So what's it going to do? It wants to, it can do 2 things. It can either gain 6 more electrons to make that those 2 valence electrons go to 8, then it's got an outside full shell, or it can lose those 2, which leaves the shell right underneath it full. Losing 2 is easier, takes less energy than gaining electrons, and so it loses those 2. Look at my new picture. The electrons are gone. Everything's the same. Still 12 protons, 12 neutrons, but now there's only 10 electrons. And so, but it's happy. It's got the outside shell is full with 8 valence electrons, octet rule. But let's look at the charge now. It's got 12 protons, positive charges, and 10 electrons, which are negative charges. 12 pluses, 10 minuses. That leaves us with a total charge of 2 plus. That's how we write that. 2 plus, like that. That's a magnesium ion. Here's another example. Chlorine, same thing. 17 is our atomic number. It means it's got 17 protons and 17 electrons. 35.4 is our mass number. And we're going to subtract, so we know it's 17 protons. 35 minus 17 equals 18 neutrons. So here are my numbers, 17, 17, and 18. And if I do my dot structures, 2 in the first shell, 8 in the next shell, and then there's 7 in the shell after that. 7 valence electrons. And so right now I haven't done anything. It's still an atom. I got 17 protons and 17 electrons, 17 plus, 17 minuses. Put it together, no charge. But it's not stable. And so for chlorine, it can either lose those 7 valence electrons or gain 1 more. It's pretty easy, and it doesn't take a lot of energy to get 1 more valence electron. So that's my red dot here. I added that in. And so now I've got 8 valence electrons, but I've got 18 total. And so look at my charge now, 17 pluses and 18 minuses. It leaves us with -1 charge. So this is how you write it for chlorine. It's stable, but now it has a charge. Okay? Finally, just to get back to our question of what kind of electrons do we have in our body? We've got lots. Here's a few of them. Potassium, these are things you've heard of. Potassium, calcium, magnesium, chloride, sodium. There's other ones too, iron. There's lots of electrons in our body. And you can write that in. Why is it important? If you saw this demonstration in class, you will remember that when there's no electrons, here, no electrolytes, they're calling them electrolytes, or when there's no ions, there's no electrical current. The light bulb doesn't go on. But when you have a lot of, look at, there's the charges. If you got a lot of electrolytes or ions in the water, the light bulb goes on. It helps conduct electricity. And if you think about the way your body works, your brain is sending electrical impulses all over your body. If you don't have the right amount of electrolytes or ions in your body, those electrical signals don't send very well, and you don't feel good, and your body doesn't operate quite as well. Also, it can cause there's pollution issues as well, and so we're going to learn more about that later on. But for right now, that is it. Have yourself a Gatorade, replenish your electrolytes right after you get done writing 2 or 3 good questions here in the margin. That's how you interact with the material. And then write a summary that answers these questions in your own words. Make sure you understand valence electrons and why they're causing atoms or ions to have a charge or not. Okay, I hope that was helpful for you. Make sure you fill out the Google form, do that summary, and I'll see you next time.